Good afternoon, sir.
Yeah, good afternoon. How are you?
Fine, thank you, sir.
All right, great.
So, sir, I was checking the calendar and I realized that we might have only up to October, I think 18 or 15, one of the two of them, for Pythons and ML.
Okay. What are you suggesting? We should try and wrap up by when?
Sorry, I didn't hear you, sir.
You should try and wrap up by when?
Yes, by is it October? So afterwards, we have to do our programming and Tableau. So by October 15th, October 15th should be our last class for Python and ML, like you suggested.
All right. Okay, so I'll work towards that time.
Okay, sir. Thank you, sir.
Yeah.
Good day, everyone. Can we start now? Hello.
Yes, sir.
All
Yes,
right.
sir.
Oh, yeah, yes, sir. We can start. Thank you, sir.
All right. Okay. That's fine. Okay. Where did we stop last week? So where did we stop last week?
So the last thing I remember, because I had like network issues, but the last thing I remember from last week was when we were saying that there's no there are no formulas, right? So we have to calculate them out by entering it like we use simple interest for an example. So that was the
Okay.
last.
Creating functions, right?
Yes, sir.
Creating functions. All right. Okay. So at this stage now, we now know how to do the ifs, is it not? We now know how to do if logical functions like the if, isn't it?
Yes,
Logical operator, if, else, elif, right? We have looked at what again? For loops, right? For loops. Okay. And we know when they are all applied, right? So you see your if function, because most times instead of you always writing that your if function, you can just put it inside. You now create your own specific function, what you want it to do. Okay, but in the same logic, right? In the same logic that you use. Because first of all, you need to understand how it's going to work, right? Then once you know how it's going to work, you now need to think about how do I now put it in a particular function so that I can always call it up anytime. Okay. So we gave an example of the if function where we want to enter our name, you enter your score, your grade, then we now say if. We start using the different if, right? And you're going to see sometimes there may be easier ways of doing certain things, right? But now that we are still learning, right? The most important thing, let it work first, is it not? Then later I'll be thinking of more efficient ways of writing your codes. Okay. All right. So we have also seen our loops, is it not? We have seen how to loop, right? So if, for example, let's say our age, we said that if age is greater than 20, is it not? If age greater, say print what? Let's say print you are a youth, right? Else, if age is, let's say age is greater than or equal to 20, then if age is greater than 18, then we say print, let's say print you are a teenager, right? Something like that. Else, so in this case, we use elif, right? Elif. Else, print you are a child, right? Now, with this work, will this work? With this code as it is, will it work?
No,
Why?
we've not defined what age is.
We have not defined what age is it not?
Yeah.
So it means,
Yes.
first of all, you need to first of all define what this age is. So in that case, we may now have to say let age be equals to maybe what should our age be? Let's say 30, right? So what will be the output of this now?
You are a youth.
Yeah, a youth.
You are a youth.
Yeah.
Enemies have come. So what's the problem?
Very simple.
The equal to sign.
Where?
Age greater than 18.
There's
We
no
should have used
space.
less than 18.
How to say, invalid in syntax. So where is the error coming from? So we say if age is not is greater than or equals to this, print if else if what? So what is it showing you here? So normally we would have just put it on this thing, right? So print
I think it should be less than 18.
here, right?
Yeah, less than 18.
But it's still giving us the
Ah.
now invalid syntax tells you that what? Once you see invalid syntax, what does that tell you?
It means you're not following the right format.
Yes, you not follow. So what do we not write properly here now? So let's say I have age is 30, right? Mhm. So if age, so let's follow it one by one. So if age is greater or equals to 20, say print what?
You're a youth.
Youth, else if age
Sir,
is
I
less,
think that's the colon. I'm not sure if the colon, should there be two colons in Elif?
Yeah, that's what I was
Like
going to ask.
colon after.
beautiful, exactly. So we have, so where is it supposed to be now?
It should be after 18.
So you see, when it was giving the error, it indicated where it was, is it not?
Yes, Elif.
Can you see that?
Yes.
Good, good. So that's a good thing now, especially once you start seeing errors, right? You should now start knowing, okay, have an idea. Even if you don't know exactly, at least have an idea, okay, what is wrong. So once you see invalid syntax, it means that something fundamental is just wrong. You see your syntax, is it not? So, because for your if function, you must first of all think about the logic, right? You must first of all think about what the logic, how you used to go, right? But there are instances where you now have to go through quite a lot, right? So you need to now start going through a lot of what things. You need to, they call it iteration, right? So you want to what iterate over a sequence, either a list, a dictionary, right? So you want to go through all of them. So in that case, you will now need to do what? A loop. Is it not? You need to what? Loop it. Okay? You need to what? Loop it. So we give an example. So let's say we have things like maybe number equals to maybe list range 1 to maybe 21, right? So numbers, so when I look at my numbers, can I say I have 1 to 20? So I want to go through 1 to 20 and multiply everything maybe by maybe 5 or multiply through by 10. Is it not? So I want to go through all of them one by one to multiply by what? 10. Right? So what do I now do in this case? What do I now do here?
I
For I in numbers,
So for I in what? Numbers.
I uh, numbers times 10.
Is that
Numbers times 10.
numbers
Sorry,
times
no. The I times 10 of the numbers times 10. Okay, numbers times 10. Let's use that one first.
okay, numbers times 10. Okay. So what do you want to do? So you should print it.
yeah, print. Numbers, print.
Numbers times 10. So let's look at it now. First of all, what do you want to what? Go through each of them, is it not?
Yes.
And
Yes.
each of them we multiply it by 10. Is it not? That's what I
Yeah.
represent. I means go through each of them individually, is it not? Good. In numbers. And what is numbers?
It's the list of numbers.
Not the 1 to 20, is it not?
Yes. Yes.
So when we say numbers times 10, what is numbers times 10 doing?
That's everything times 10.
That is, see numbers times 10 or numbers times 10. It means like duplicate it 10 times. That your list duplicate 10 times.
Oh, okay. So it
You
should be I
remember?
times 10.
Yes, now, if you remember, if I have maybe A is equals to 1, 2, 3, 4, 5, is it not? And I say A times 10. That's what it's doing. It will duplicate that list 10 times. Is that what we want to do?
No,
No,
it should be I times 10.
it should now be what? I times 10. Can you see that now? Then we'll go through. So it is the I you use, not the variable.
Okay.
You get? It's the I you use, not the variable. Okay. All right. I think that's clear, right?
Yes, sir.
And again, remember, most times as data analysts, the calculation we want to do, we want to create it inside another variable that we want to use. So just imagine like you are working with Excel, you want to do a calculated column, you want to calculate a new column, right? But in calculating that, you will now need a helper cell or a helper column. That is exactly what this is doing for you. It's like a helper column or helper cell. So we want to create it in a new place. Maybe let's call it results. So we will now create it inside what? An empty list. Is it not? So when we create inside the empty list, we'll now say whatever calculation we have, store it for me inside that what? Empty list. Okay. So that's why we can say for I in what now? Numbers. Is it not?
Yeah.
What do I want to do?
Print.
Now I don't want to print now. I want to put the result. I want to put the calculation inside that result.
Okay. What's the result? No.
Is it?
For I is equal to result. No.
I equal to result. Will it work that way?
No.
Now you know once you have put your at this point now, for I in numbers, now we put the expression. What's the formula do I want to put? So let's say maybe A is equals to what? I times what? 20. Right? That's the expression.
Yeah.
That's the expression. Now what do I want to do with it? I want that result. So I want that result. I want to append that result. Append what? What am I appending?
A.
I want to append A. So it means what? So it means that first of all, create an empty list. Is it not? Now I want to iterate. Means I want to go through each of them. For I, so go through 1 to 20. Right? So what you are writing here is the same thing when they write it mathematically. From x, you know how they write from x equals to 1 to n. Is it not?
Yes.
So that's like an iteration. So it's going from I to n. So they write it mathematically like this. When you see your formulas. But actually, this is what is going to go through all of them to the last. Okay. Now, what do I want to do? I want to what? Create what? Go through each of them and multiply through by 20. Whatever I have, I will put it inside this result. So that's why I have result.append. Okay, result.append. So let's see that. So it means like nothing happened now. So if I say result, so if I want to put everything straight, I can come down here and say print result. So if I want everything to show immediately, I say print result. So can we see that now? Print result. Okay. Print result. So we have gone through each of them, is it not? Then we'll now append. Right? We'll now what? Append it. And again, sometimes instead of you even going through this, you can just write it at once. So instead of we can also do it this way. That instead of, you see how many lines of code? This may be 1, 2, 3, 4, 5, right? So instead of doing this here, you see this A. This A represents everybody here, is it not?
Yes.
So it means that instead of me calling it A, then I should just be able to what? Take only this one
And put
right,
it there.
and represent it inside here. Can you see that?
Yeah.
I'll just take it and represent it inside here, and it will give me the same results. So do
you
see
got
difference?
the same result?
Yeah.
No.
You say what?
No, I tried something like that, but it gave me a different. Yes.
Now
It gave
because
me.
You know, we are still running exactly the same thing now, right? So
Yes.
it will give us a different result now. It's unless if I have going to use results to now multiply through ahead and it will give me something else. So you are going to see now that when you are writing your code, you see that some will be easier than the others, right? But when we are learning, we'll bring everything at once so we can see it step by step, right? But much later, when you start to see, right, you can now say, okay, since I know it like this, because the less code it is, the better, right? So you don't want to write long lines of codes to do one little task when I can write it in 2 lines, all right? If I can write it in a single line, it's even better, isn't it? So the smaller it is, the better. But the important thing is that you'll be seeing the different ways to write it, all right? We'll see the different ways to what write them. All right. I hope this is clear. Is this clear?
Yes, sir.
All right, good. So the next thing we had looked at was more like writing your own functions, right? Writing your own functions. Okay, I think we also talked about list comprehension, right? We also talked about list comprehension. So for list comprehension, let's say, for example, I have that, let's say result, right? Result. So what was the formula that we had written? We were reading I times 10 raised to power, is it not? 10 times 2, is it not? So I want to now what? Iterate through it and append. So in that case, instead of me first of all writing my range, where's my range? So I wrote my range 1 to 20, is it not? Inside numbers. So it means this one would have come. Let me write it out. So I can paste it here. Where am I copying it from? Copy. Okay, good. So it means I would have done all this now. So that's why I'll write the numbers out, the list of the numbers, put it in an empty list, you know, then now I iterate through. Isn't it? We'll now iterate through. So which means in this case, instead of me doing that, I want to put it inside the list. So you see this result now, I want to put it inside the list, right? What's my expression? I times 20, you know.
Yes.
Then I will go through. So for I in what? Range what? 1 to 21, is it not?
Yes.
Then what did we do? So let's run it and check. So results. So we have 20 to 48. Is it not the same thing?
Yes.
So you see what I would have still used to write 1, 2, 3, 4, 5, 6. I can just write it in one line. Is it not? It's only if I want to now complicate it further again, then I can now start adding other, maybe I can start adding other things now. For example, I'll say now, if what now? So do that if maybe I modulus 2 is equals to what? 0, which means that what does this one now mean? Or if I say if I is greater than 10, what does this mean now? Okay, let's see if I is greater than 10. So what does this mean?
The numbers that are greater than 10, you multiply them.
By 20, right?
Yes.
Okay. So let's see results. So it means that it's going to start from where?
From 11.
So you start from what? 11, is it not? So you start from here. Can you see that? To now start from there. So that way you are seeing up to this point. Have you seen it now? So this is called what? It's called what? A list comprehension. You see, the same thing that I would have done here, I can use one line of code to now do that. Okay, so that's what is referred to as what? A list comprehension. A list comprehension. All right. So let's quickly go to functions. So we see sometimes we can now write our own, right? Because sometimes we want to perform a particular task. Because as analysts, most times, like in Excel, where you have your different functions equal to maybe average, equals to sum, right? Now you can also have your own functions that you write. Because for example, in Python, they are by default, right? You have to write everything from scratch. But to do that, they have now functions. You now have to import them. Now say import. Maybe sometimes you hear things like import pandas, right? Import numpy. They are now like libraries, but those libraries contain so many word functions. Okay, but what are they used for? So a function is just used to what? Calculate, right? Or perform a particular task or return a particular value. Okay. Now, before we do that, we need to first of all understand what we want to calculate, isn't it? Last time we calculated, what did we calculate last time? I think we gave, was it area or principal interest? Which one did we do last time? Which one did we do the last time? Which example did we do last week? For
We did
functions.
we did for converting exchange rates.
Okay,
Like we did simple
converting
interest.
what exchange rate, is it not?
Yes, and we
Converting
did
what
simple interest.
Yes, simple interest, is it not? We did simple interest. Now, just imagine now, we want to convert. Maybe you know how you want to convert your maybe feet to inches or inches to feet, right? Inches to feet, right? Now we know that. So how do we calculate it? So let's say inches, right? So if you look at your ruler, in cm, you have maybe like 1 to 30. Is it not? In cm, you may have 1 to 30. So which means that if I want to now do a calculation, maybe from feet to inches now, from feet to inches, or inches to cm, right? So you need to first of all know how it's being calculated. Is it not? You need to know how it's being calculated. Okay. Now, if we know how it's calculated, let's give an example. So how do we convert? What's the conversion rate for inches to feet or feet to inch cm?
1 inches.
That calculation. Yes.
12 inches make 1 feet.
Okay, 12 what? Inches make what?
12 inches make 1 feet.
Make 1 feet.
1 feet.
Okay. 12 inches make 1 feet. Okay. Good. So which means if I want to now convert from feet to inches, what do I now do?
Multiply by 12.
Divide by 12, I mean. Right.
So this is 12 inches, right? 12 inches equals to this. So if 12, so 1 feet will now become what?
12 inches.
So 1 feet is 12 inches. So if I now have maybe 30 inches, convert it to feet, what do you now do?
Divide by 12.
You divide by 12. So since I don't know
Yes.
this, I don't know this. So this will be my x, is it not?
Yes.
This will cross multiply, is it not?
Yes.
Will cross multiply. So if you are cross multiplying, that means x is going to be the same thing as what? 30 divided by what? 12. Is it not? This is how I would have calculated it. Right? This is how I would have calculated it. But if you are doing it the other way, so maybe I now know, okay, this is 30 feet. 30 feet to inches, what will it be? 30
Multiply.
inches. I know that 12 inches is equals to what? 1 feet. Now I know that 30 feet is equals to what? X, is it not? So what do I do in this case? I'll just cross
Multiply.
multiply. So it means that I will have x is equals to what? 12 times 30. Is that not? Can you see that? So you see, if this is not clear, then just forget about what you are trying to build. Because it's not about building your writing your code. Now, it's not. It's first of all understanding what you want to achieve first. You see that? You need to understand what you want to achieve first. Now that we have got this, now we want to write. So let's say first I want to write what? A function that does this calculation. So we want to write a function that what? Converts what? Maybe inches to feet, right? Is it inches to feet or feet to inches? We want to convert feet to what? Inches, isn't it? So in that case, we now need to define, right, the name of the function. So what do we call the function? What should we call the function?
Feet to inches or
Okay,
feet underscore inches.
feet to inches, like this, right?
Yes.
So what I've written in name. So what are my parameters? How many parameters do I have?
2.
I have 2
No.
parameters.
What?
How many?
It's 2 now. Feet and inches.
Feet and inches, yeah. No,
Okay,
I think it's 1. It's just 1 now.
So which one is it?
The person inputs their feet and it converts it to inches.
So
Yes,
if we
it's
look
feet.
at this, it means that 1 feet is equal to 12 inches,
Yes.
right? 1 is a constant,
Mm-hmm.
is it not?
Yes.
It means that 1 is a constant, right? 1 is a constant. If we know that 1 is a constant, then in that case, we can now say, okay, my feet, so let's say we have feet equals to maybe, what will feet be now? 12 inches, right?
Yes.
Or let's leave it as, so which one should we, do you want us to use 1 parameter or 2 parameters?
I
Because it
think
means that because 1 is a constant, right? Because what we would have done normally, we would have just said, okay, let me set whatever this fit is going to be, right? I can
feet is
set a
equal to
particular
12.
parameter, is it not?
Okay.
So 1 feet is 12 inches, right? Then we can say that our inches, is that inches? Maybe something like this, right? So it means that 1 is a constant, right? But if you
Okay.
don't want to do it that way, then it means I'll just only put 1 parameter.
Yes, 1 parameter.
I'll just only put 1 parameter. And what I'm trying to convert is what from feet to inches. So what I need to put is the inches.
Yes.
Is it not? What I need to put is the inches. Then if I have done that, if I've defined it, then what is the expression? So I can even define what is there. So I can say what? Convert what?
Feet to inches.
Yes, convert from what? Feet to what? Inches.
Inches.
Is it not? Good. So what's the function now? So let's say what now? Feet to inch, right?
Yes.
To inches. So maybe I can just put a formula A,
Okay.
right? Or you see we're using X there, so let me use X. So X is equals to what? X is equals to what? X is equals to what?
The constant
12
times
times, is it not?
Yes, 12 times
12 times what?
inches.
inches.
The inches, right? 12
Yes.
times what? The inches, right? 12 times what? The inches. Then what do we do now? We're now going to what? Return what?
X.
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 Is it not?
Yes.
Return X. Which means when we are doing 12 times 30, is it not? 12 times 30 will give us what? 12 times 30 will give us what?
360.
360.
So it means that 30 feet to inches will give us what?
360 inches.
So it give us 360 inches, is it not?
Yes.
360 what?
Yes.
Inches. So it means we know that our inch is 12. Is that it?
We know our feet is
We
12
know
feet
our
make
feet.
1 inch.
We know our feet, right?
Yes.
We know our feet already. So
Yes.
1 feet gives what? 12 inches.
12
So
inches.
anytime
Yeah.
I see 1 feet, it represents 12 inches. So
12.
now this
Yes.
is inches to inches. They are not in the same
Yes.
base.
Yes.
Is it not?
Yes.
Now you see, if you do not understand this mathematics, then there's no way this one can make sense. You see that? That why what you are trying to understanding what you are trying to do. You see, when we say understand basic mathematics, you see, we are not saying we are deriving anything, but at least you should understand how to do basic conversion, how to do basic calculations, isn't it? So let's run this and now check now. Okay, so now we have reached, see, all these things we have done here, we have now written it here now, is it not? So now if I want to now call it up now, right? We now know that what? We want to now convert 30 feet, is it not? We want to convert 30 feet. Okay, so what's the name of our function?
Feet inches.
Eh?
Inches.
Feet inches.
Yes, feet inches, is it not? So if I run that, you can see it has already recognized it as what? It has recognized it as a function already, is it not? Now, how many arguments or parameters do I have?
Just one.
Just one, is it not? So I put 30. Can you see that now?
Yes.
It gave us exactly what we calculated here. So the point here is that before you even write anything in codes in Python, first of all, you must understand what you are doing here. You must know how to do it on paper first, is it not? The only reason why you are writing it is in case it now comes so many times, right? I don't want a situation where I now have to start writing it over and over again. So I'll just write one simple code that can help me do it. Okay. So that's where your functions now come in. Because you see, when you write the functions, right, it can now be used anytime. So anytime I want to, I can just call it up. So that's why you are going to see that when you are dealing with certain calculation, we can now have to start with importing. Now say import. So there are so many libraries or functions that they are being stored in Python, right? So whenever you see a function, right? Whenever you see a function generally is what? It's just to enable you perform a particular task or return a particular value. Okay. Now you are also going to see that there are two things you are going to see. One of them is that I need to define the function first. You know, that why we use the keyword define, DEF. Is it not? So we are going to define it. Then we are going to use a keyword. You see, the keyword now is blue, is it not? Which means we have defined it as what? A keyword. So when we say something like int, you see int is a keyword. I see a different color. If I say sum, right? If I say sum, if you say float, you see they are keywords. So the same thing with your what? Define what? These are feet to inches. It's not a word keyword. Okay? It's not what? A keyword. Now, what you are going to put inside it, right? What you are going to put inside it, they are called your arguments. They are called your arguments, or sometimes you can call them parameters, right? So, for example, if I say this my inches now is a parameter, is it not? So a parameter can be anything in this case. Just think about it like a variable. Oh, and that reminds me again. You see, when you talk about variable, let's say when we talk about a variable, you see x here. So let me write this. If I say x is equals to 20, right? If I call up x now, what should x give me?
20.
20. You know, x should give me
20.
what? Now remember we're talking about a variable, is it not? We say a variable is any container, is it not? That can store anything there, is it not? A variable
Yes.
that stores anything. This x you are seeing here is referred to as what? A global, it's called what? A global variable. It's called what? A global variable. It means it can be used anywhere. But you see this x inside here, it is only within this function. So it is referred to as what? It's called what? A local variable. Can you see that now? So we have now defined variable as two. It can be a global variable or what? A local variable. Do we get that now?
Yes.
Do we get it now? So when you just see it generally like this, so this is called what? A global what? Variable. But once it is inside a function or inside something else, it is now called a local variable. Do we get that now?
Yeah.
So this was an instance where we just have only one parameter, is it not? Remember, this your x here that we are putting here, right? Or whatever variable we have here is what we also call a parameter. So when they ask you how many parameters is it not? How many parameters? So that your x is a parameter itself, right? But when you are writing it inside a function, when you are writing inside a function here, then it's referred to as what? An argument. Can you see that? When you're writing it here, they will call it what? A parameter. But when you're not calling it up, when you want to actually write it now, you don't call it an argument. So sometimes they use them interchangeably. Okay? So when you now call your function now, is it not? You enter that name inside your function, we call it what? An argument. But when you are defining it, it is defined as your parameter. So sometimes they will use them what? Interchangeably. Do we get that? So whenever they say missing parameter or unknown parameters, you should understand what they are saying, isn't it? If, for example, we say define, let's say we say define hello, right? Define hello, right? I will now say print, let's say print hello Francis, right? Good. So what have we done here now? Okay, let me first remove it like this. So let's do it like this. So say define hello, right? Now, how many arguments do I have here?
There's no argument.
There's no argument, there's not.
Mm-hmm.
There's no what argument there, right? But
Mhm.
if I write x, how many arguments do we have or parameters do we have here?
One.
One, is it not? So we have just only one word parameter in this case. So this, what's the name of the function now?
Hello.
Hello. So the name of my function is called what? Hello. Isn't it? So if we now say, okay, print, maybe print hello, let's say X, right? Print hello X, is it not? And I say, you are welcome. So what are we trying to do now? Whatever I have here, I now define it, is it not? So if I say hello Francis, so it will now tell me whatever the person name I put here, just say hello Francis, isn't it? Hello Francis. Okay. Now the same way, in this case, you see this X here has now become what? This X here is what? That I use in this case is now what?
The global variable is the X
It's a
one.
global variable. You see where the difference is between a global and local variable. A local variable can only work within that function. But a global function can work anywhere. Can you see the difference now?
Mm-hmm.
You see the difference between a local and what? Global variable now. Do we get the difference between a local and global variable now?
Over it again.
Eh? So what we are saying is that generally when we just say A is equals to 20, this is what a global, it can be used anywhere because I can call it up anytime. Okay, but whenever I'm writing it a variable now, when I say I'm not defining it within like a function here, it cannot be used anywhere. So if I have A here, this A cannot be used anywhere. It can only be used within this function. That is why it's called a local variable. Do you see that? It's just the same way we have interest rates. So let's say we're calculating interest rates, right? So if I say define interest, maybe how many parameters do I have? I need principal, I need my rate, I need my time, right? Now I now have A is equals to what? Principal times
rate times time.
times time. It means here A is what?
A local variable.
A local variable. A is what here?
Global variable.
Global. That's just the difference. Because only within here that I want to see, so I cannot say return A. Is it not? So within the function here, we now have a local variable, right? Why, when we're writing in general, it is called what? A global variable. Is that clear?
Yes.
So that's why there are some concepts that we use anytime I'm going over the same thing that I've taught before. You see, there's always a new thing that we add to it, right? Because whenever you start, why don't start breaking and telling global and local variable? At that point, you may not really get it. But generally, when we're talking about a variable, they are actually referring to global variable. But more technically, there are two types of variable: a global variable and what? Local what? Variable. Okay, so what we are saying that when you are writing your functions, right, you must first of all have an understanding of how it's normally calculated, what it's doing. You know, once you understand it on paper, then I will now try and build it. You know, first of all, I need to define the keyword, right? I will now define it first. You know, then based on the formula or the expression I have, I will now need to identify how many what parameters or arguments I have. Okay, because you see, if you don't call the number of arguments here, so for example here, if I want to call it, so interest, right? So interest, so if I now put here 10(2), I run it, it's telling you that what?
Interest is not defined.
So what does that mean now? Interest name, interest not defined.
You didn't run it.
We didn't run it
I didn't run it, is it not? How do you know it has not been run?
because
You see,
it's
this
the error
line is
message.
blank.
Okay,
And
okay, okay.
see, this line is blank, is it not?
Yes.
So you know you have not run it there. You see, now I have run it, you see that there's a number there.
Yeah.
So let's run again. Now, what does it tell
Even
you? Interest,
argument.
listing one required positional argument. Can you see that?
See.
So what I'm writing inside here, inside the function is called what? An argument. Is it not? So it's an argument. So argument T, it was even telling you. So if I now put T, maybe time 5 years, maybe interest 0.2, then I can now run it. So you see, whatever I'm now writing inside the function is referred to as what? An argument. Do we get that now? Is this clear?
Yes.
So the same way, you know how we write, maybe we have maybe 1 plus 2, you know, plus 3. Let's say plus 3, you know. So we have 1, 2, 3. So it means mathematically the expression is I plus I1 plus I2 plus I3, you know. So it depends on how many parameters. So it means here, how many parameters do I have here?
3.
3, is it not? I have 3
Yes.
parameters. You know, so if I want to write a function, so you know in Excel, it says equals to sum of, is it not?
Yes.
Sum of, then you now write the function there. So that's exactly what you are trying to do. You are not trying to write your own function, right? But in this case, your own function can now have what? A given number of parameters. So I can now say define maybe some values. Is it not? Define sum by, or let's say define sum. Define sum. But let me use a new name so that we don't have issues. So let's say sum values, is it not? So I will have A, B, C. Is it not? A, B, C. What's the expression? I can now say A is equals to what? A plus
Plus
B
B
plus
plus.
C. Is it not? Then I will
Yes.
now return what?
A.
A. Now, but avoid this type of problem. So let me call here X.
Mhm.
Yeah? So let's return it as X. Can you see that? So in this
Yes.
case, how many parameters do we have or arguments do we have?
3.
3, is it not? So if I say some values, I write 1, 2. What will it give me?
Error.
It will give me what?
An error.
Why?
Because you didn't put the required amount of
Because I don't
parameters.
have the required number of what? Arguments, is it not?
Argument.
So if I now put another one, let's say 10 or 100, now it's going to work for me. So before you write anything, you must first of all be clear about the expression, how it works first. Then that's when you now start what? Building it. Because as analysts, most time, right? We need, especially when you are now dealing with a particular domain, like in finance, you are an engineer, is it not? There are certain formulas you need to start calculating, isn't it? So you will now have to write that function to do that calculation. Okay? So this is where those arguments now apply it on that particular column. So it will do all the calculations for you automatically.
So in how Excel is that you can put an infinite amount of numbers and it will always sum them up.
Exactly.
If we're going to do such how we, because now we're limiting the parameters by putting A, B, and C.
Okay,
So if we wanted the
number, right?
Yes,
now when we
infinite.
get to, I will do that. When we get to, I'm still building it gradually, right?
Okay.
I'm still building gradually. I don't want to start putting so many things at once. We have not gotten that to that stage yet.
Okay.
But we'll still do that. I'll show you where you cannot enter anything that you want.
Yes.
You get we'll come to that stage, right? So we're just building it gradually, right? We are just building it gradually. Then we'll start doing that. Is that okay?
All right.
Yes, we'll get to that stage. Why I normally use this method so that we'll just understand the basics first, because by the time you start adding different things, someone will now be wondering, hey, where do all these things come from? Do you get it? So I don't want to scare you guys first. So let's just build this small, then I will show you an example of how it's done later. Okay. So these are how you normally would write your own functions, right? This is how you normally would write your own function. That is why, for example, there are already inbuilt functions or libraries already inside Python. For example, you can say, so if I want to get random numbers, there's no, in Excel, how do you generate random numbers in Excel?
Random or round.
So equals to rand. Rand normally will give you in a decimal, rand, is it not? Then if I want to now write maybe in whole numbers, it will be what? Rand between, is it not?
Yes.
Rand between goods. So in Python, for you to do such a thing, you now have to import the library. It means somebody has written those functions for you. Somebody has written, and for example, like if I have maybe like, let's say, I have maybe, let me say A is equals to Francis, right? Then if I say length of A, what does it do?
Counts the
letters.
It will count it.
characters.
You know that this is also a function. You know this is a function.
Yes.
This is an inbuilt function. Do you see that? This is already an inbuilt function. So in this case, you are now customizing your own function, right? But when you now have a group of functions now to carry out a particular task, they now refer to them as what? Libraries. They now call them what? Libraries. They have already been written for you in Excel or in Python already. So what you now need to do, the way you have written your own function, somebody else, people have already also written their own function. So what do? You now need to what? Import the function. So you now say what? Import, then the name of the library. So let's say maybe random. Can you see that? So I've imported the function, the libraries now. So it's called what? A library. Okay? It's now called what? A library. So the same way you hear of import pandas, right? You hear of import numpy. Have we heard of pandas before? Not the fluffy animal, pandas, right? So the way you think about Excel, that's how pandas is. That's how I think of pandas. It's just like your Excel inside Python. That's your pandas.
Okay.
Right? So, but it's already a library already written with so many functions, right? With so many functions. So you need to start with importing them. So anytime you want to import what other people have done, other libraries or functions you want to use, because the libraries will contain several word functions. The libraries will contain several word functions. Is that clear?
Yes, sir.
Good. So in order for us to now do that, we now have to import what? We now have to import those libraries, right? And sometimes that library, they also call it a module. They may call it a module. So the libraries, they also call them, so those libraries, sometimes you also call them a module. A module, right? So it's just a collection of predefined, like what's the difference between a function and a formula in Excel? What is the difference between a function and a formula in Excel?
I think the function has been pre-installed. The function has been pre-installed.
Yes. Okay. Why a formula?
You just create
you create it yourself.
Yes, it's the expression, it's not the mathematical expression, it's not.
Yes.
So it means libraries or modules are pre-written Python code. It's not. So it means somebody has already done it before. And this is what makes Python very unique, because it has so many libraries that people have done. You don't have to write them from scratch. You see that?
Yeah.
But actually, that's where you now differentiate the real people who are real coders, right? They write everything from scratch, even to add, to subtract. They will write their own. You just say minus this. No, they will write their own this thing. It's hard work, but still doing the same thing, right? So this is where you don't see that Python makes life very easy, because there's a huge community, of libraries already written by so many people. So you don't even stress yourself at all. All you just need to do is, which is the relevant libraries I need to achieve this particular task. So whenever you hear a library, I need to import this library. What are they telling you?
Try to
So when you hear a library, simply means what?
Functions, group of functions.
Group of functions already pre-written, is it not?
Yes.
Pre-written Python code already to achieve a particular word function, is it not? So we don't have to import those libraries or modules, is it not? But the function is the one you're not going to write, is it not? That will not be reusable. So whenever you are writing a function, it means you are the one creating it yourself. But the ones other people have written, you don't have to bring it in. We call that a library or a module.
Module.
Do we get that now?
Yes.
So if I want to get random numbers now, by default, it's not an inbuilt. So we have to import it. We now have to import it. So I can now say maybe num is equals to random. So random is what? What is random? Random is what?
Is a function. Is a function.
The library.
Oh, it's the library. Okay.
It's the library, is it not? It's the library. Now the function can now be rand int. Can you see that? What is rand int now?
Okay.
That's
Rand int
Random
means give me random numbers, let's say between 1 and 20. Do you see that? I'm now storing it inside what? So if I say num, it will give me any random number. Can you see that now? Do you see that? So the same way, if I wanted to generate random numbers, let's say between 10 and 100, okay? But now say, okay, this is how we would have normally done it. We would have said list range maybe 1 to maybe 21 or so. Is it not? You just give me a list of numbers like this. But now I want random numbers. Can you see the difference now? I want random numbers. Okay. So in that case, what I would have done, I would have said maybe A is equals to random dot, I want a sample. I want a sample. So give me a sample within that range. Range of what? Let's say 1 to 21. Is it not? Give me how many random numbers do we want? Yeah?
10.
10. Okay, 10. All right. So can you see that? So give me 10 random numbers. You see that? 10 random numbers. Do you see where a library now helps you? You see where a library now helps you to do these things? Because normally what we were doing before, we just write a list. But I don't want the list. Okay, I have the list. Now inside that list, now give me any random number now for me. So you see where libraries now will come in. Then we have inbuilt functions. So like I can say max of A. Is it not? I can say minimum of A. Is it not? I can say mean of A. Is there anything like mean of A? There's not like mean of A. Is it not? There's nothing like average of A. So how do I now calculate it? If I want to now calculate the mean now, I'll say mean is equals to what? Mean is equals to what now? So how do you calculate the mean now?
Mean
Yes, how do you calculate the mean? Yes, if I want to calculate the mean now, there's no function for mean now. So how do I calculate mean?
The sum of all the numbers. So sum of A divided by the count.
1, 2, 3, 4, 5, 6.
Sum of A
Yes. Divided by the count number of divided by the number of the count of the numbers within A.
Okay. So look at it now, right? So this is what you have. What we'll do. We'll first of all say the mean is equals to what? We need to sum now, is it not?
Yes.
We need to sum. You see, basic mathematics, is it not? It means that if I have the numbers, summation of x, is it not? Divided by n.
And
Is it not?
yes.
Divided by n. All right. Good. So it means I will first of all add up those things. So sum of what? Sum of what?
Sum of A.
Sum of A
Over
divided by what?
count of A.
Divided by what?
Length of A.
Length of A.
Yes.
Yes.
Sorry, length of
Yeah.
A.
Length of A, is it not? So you see this
Yeah.
case, we're not defining it ourselves. We're now building it ourselves. Right? We're now building it ourselves. Okay. So what you are saying here, there are some libraries, you know, that we already have inbuilt functions for you to do. So there are so many libraries, right, that you can use. This is just an example, but subsequently we'll start introducing us to what different other what libraries, right? So here we see, and in those libraries, remember we have talked about what a global variable, we have talked about what a local variable, is it not?
Yes.
We have talked about global variable, we have talked about what local what variables, isn't it? Because when you are now dealing with it, when you are now seeing some certain errors, because inside this function we have certain what local what variables, right? So you now need to understand what it's actually trying to what achieve. Okay, and that's why when you are dealing with, especially when you are writing your functions, right? There are some instances, let's say for example, we have something like this. Maybe you want to do a calculation, maybe you know how in mathematics you want to write something like, maybe you want to write something like 3x plus maybe 2, is it not? 3x plus 2. So maybe I'll say that y is equals to 3x plus 2. Now, where we now say where x is equals to 0, what is y?
Y is equals to 2.
Y is equals to what?
2.
Because this 0 will now replace this, is it not?
Yes.
0 times 3 is what?
0.
0 plus 2 is what?
2.
Therefore, y is equals to what?
2.
Basic mathematics. Which means we must be clear about how the function works. You know. Now, in this case, how many parameters do we have? How
2.
many parameters do we have?
2.
What are they?
X and Y.
X and Y. What do we say a parameter is?
Parameter is a value for a function. A value within a function.
The value within a function, is it not?
Yes.
What is Y?
Y is the function.
Is Y the function?
Y is equals to, no. Y is the variable.
Y is the variable, is it not?
Yeah.
Y is unknown.
Y is the variable, is it not?
Yes.
To calculate this, is it not? This is our expression.
Yes.
So how many parameters or arguments do we have here?
1.
1, which is what? Just your x.
X.
Can you see that?
Yeah.
Yes.
So see why you must be clear on parameters, Now, if you are writing this within a function, then y becomes what? If you are writing it within a function, y becomes what?
Parameter.
No,
Within
y
a
becomes
function.
the
Within
is
a
the
function. If I
function.
now say define maybe sum x, is it not? Then the expression. Now, in that case, y now becomes what? Y becomes what? Within a function. Yes, y becomes what?
Why?
The local
Why?
variable.
It's called what? A local variable now. Is that what the local
Oh,
variable?
I was thinking too much. Yeah, look how
Yeah,
variable.
you're thinking too much, exactly. It's the local variable. But if I had written it on its own, then y here becomes what? A
Global variable.
variable. Do you see that now? Do you see that now? So you must always ask yourself, okay, how many parameters do I have here? Because you know, the same way you write a function, right? You know, when we're writing a function, we'll first of all start by defining. You know, we'll first of all start by defining the function.
Yeah.
You know, we'll start defining the function. We'll now put the function name. Maybe, let's say, sum x or something like that. You know, we'll now put the parameters, maybe x. You know, they will now write the expression. You know, I can now say y is equals to what? Y is equals to what? 3 times x, is what?
Yes.
Plus what? Plus 2, is not?
Yes.
Then return what?
Why?
Can you see that? Return y. You see the way you write it on paper, 3x plus 2. You cannot go and write 3x just like that. So you know the implication. It means it's 3 times x.
Yes.
You see that?
Yes.
So which means this is what we have written here. You now see within here, y becomes what?
The local variable.
It's local variable, is it not? So if I run this, right, and I say call sum x. Now, if I write 0, what will I have? What will I have?
2.
Give me 2, is it not? If he has given me another thing, you know that something fundamentally here is wrong, isn't it? This is what we have done, is it not? But you see, there are instances where instead of me writing a function, right? Because first of all, I need to know the name of the function. Is it not?
Yes.
But sometimes I don't want to start going through this process. I just want to write one line of code. So you remember how we did it with our list comprehension? We'll just write only one line of code just to achieve the same thing. So in that case, we can also write a line of code to also do that. But instead of you calling it this name of the function, we'll use an anonymous function. They call it what? Anonymous. When you say something is anonymous, what does it mean?
Unknown.
Unknown, is not anonymous. Anonymous. How do they spell anonymous? A-N-Y.
A-N-O-N-Y.
NY.
A-N-O-N-Y.
NY.
Yes.
Yes.
Anonymous.
M-O-U-S.
Anonymous function. You know, unknown. It's not. I don't need to what start defining that function name. But yet I want to what call it. It's not. So we refer to it as what? Lambda. We call it what?
Lambda.
Lambda. They call it what? Lambda. So they're called lambda function. So whenever I hear write a lambda function, what does that mean? Write what? An anonymous function. It means a function without name. Do we get that? So what we would have done here, we say define sum of x. It means sum of x, this sum x means what? That's the name of the function. But I don't want to write the name of the function down. I just want to write it straight. Okay, I just want to write it straight. So I'll first of all write lambda lambda. So lambda, can you see that? So lambda represents what? So when you hear lambda,
Anonymous.
lambda means what?
Unknown. Anonymous
Unknown.
function.
I don't know the name of the function. So instead of me calling it sub x, I'll call lambda. Lambda represents any name you like. Okay. What was the function that we had written?
Y.
Y is equal to 3
Yes.
times.
But how many parameters did we have?
1.
One. Is it not? So I'll say
Yeah.
lambda x. So lambda x means what? I want to only have what? One parameter. Is it not?
Yes.
What is my expression?
Y is equal to 3.
3x plus 2.
3x
My
plus
expression
2.
is what?
3x plus 2
3x
times x plus 2
plus what?
plus 2.
Plus 2, is it not?
Yes.
3x plus 2. Now I can call it inside a variable. Let me call it inside a variable. Let's say a. Right? Let's call it inside the variable a. Right? So which means if I call a here, you see, is a lambda function, is it not? Now, how many parameters do I have? How many
1.
parameters do I have?
1.
1. So that's just the x you are seeing here. So if I put 0 here, what do I get?
You get 2.
2. Can you see exactly what I have done here is exactly the same thing I'm doing here. So there are certain times where I don't want to start creating a function. I just want to include, I want to write a function, but I just want one line of code to do that same task. In that case, there are sometimes you need to use lambda function because you want to embed it inside another code. So instead of me writing this to make it longer, I can just use a lambda function to do the same thing. Do you understand this? Is this clear?
Yes, sir.
Is this clear? Okay, let's assume, so see the first one we have done, we did something like this. That y is equals to what? 3x plus 2, is it not? So in this case, how many parameters did we have? How many parameters did we have?
1.
We had one parameter. What if I said, okay, z is equals to 4x plus 2y minus 1? So how many parameters do we have in this case now?
2 parameters.
2 parameters. What are they?
X and Y.
X and Y. Z is what?
Variable.
A variable, is it not? It's a
Yeah.
variable. It now depends on where it is to either be a local variable or a global variable.
Yeah.
Is it not? So if
Yes.
it's within a function, then it becomes a local variable. But if it's on its own, it now becomes what? A global variable. Isn't it? So
Yes.
which means if I have two parameters here, so I want to write a lambda function. So how do I write a lambda function for it? So I can say z is equals to what? Z
Lambda.
Lambda.
Let's
Lambda. How many
use.
parameters do I have?
You have 2 parameters.
So what are the 2 parameters?
X,
Well,
Y.
Can you see that? X,
Yeah.
Y. You see that now? If I have
Yes.
3 parameters, it will be X, comma, Z.
Okay.
You see that? Good.
Yeah.
Then what's the expression?
4 times X.
4 times what?
X plus 2 times
plus
Y
2
times Y
times what? Y,
Y. Minus 1.
minus 1. Isn't it? So I've
Yes.
written my lambda function now. So it means Z, so let's put here where X, so where X is what? Let's say 2, and where Y is equals to 5. Is it not? What is Z? What is Z?
8, 8,
So this
10,
is 2 times what?
17. 8, 8, 10,
10
So this is
minus
8
1.
plus what?
10, 18
10
plus 1.
minus what? 1,
1,
is it not? To give us what?
17.
17. Is that not?
Yes.
Yes.
So when I want to call it up now, how do I call it? So it will be Z what?
2,
Z in brackets
2, 5,
2 and 5. What do I expect to get from here?
17.
whatever two numbers, 2 and
17.
So
2
if
and
you
5.
give me another number, it's not. So I have created what? A lambda what function. So if you remember how we created, we wanted to calculate interest rate, is it not? Simple interest. How do we calculate? It says define what? Interest, is it not? Then we'll put the parameters x, p, r, t, is it not?
Yes.
Then what do we do? We now say int
Yes,
is
break
equal
down.
to what?
E times R times
3
T.
times R times T.
Times time, is it not?
Yes,
Return
return
what? Interest.
interest.
That's what we did, is it not? Then
Yes.
interest will now be what? Let's say 100, 10,000, comma what? Interest rate, let's say 10%.
0.5.
Then let's say for 5 years. What did he say?
No, it's interest. It's interest.
Interest,
That we should
okay.
write, not
Yeah, it takes out most. Yes. It's the spelling of the interest.
Yes, the interest, right?
Yes.
I didn't make mistake in the interest too. Oh, enemy. So interests. Okay, good. Interest. All right. So that's it, is it not? So how do I now write a lambda function for this? So imagine I want to calculate a lambda function now. How do I do it?
Interest is equals
So
to
interest is equals to what?
lambda
lambda
P R T P comma
so
R
P,
comma
R,
T
comma T here.
colon.
Good.
So it's P times
times R times T.
R times T.
That's what we are done now. It's not. Is there any other thing again we want to do? It will now be
No.
what? P times
Times
what?
R.
R times what? T. So it means if I want to now write it now, right? So I'll just say interest is going to be what? Maybe what? What do we have here?
Brackets.
10,000, comma,
0.1.
0.5.
Right.
And we have the same thing. So these are called what? Lambda functions. I hope this is clear. Is this clear?
Yes.
So please do this last one again. This interest from line 61.
Okay, here, right?
Yes.
Okay. So here you want to do a calculation, right? To calculate interest in primary school. Isn't it? They told us that interest is equals to what? Principal times what? Rate times time. Isn't it? This is what we are told now.
Yes, that's right.
This is what we're told. Principal times rate times time. So once I know that this, how many parameters does it have?
3.
3. Principal, rate, and time. Isn't it? So
Yes.
this is the formula. This is the formula we learned in primary school now. The formula.
Yes.
So I want to create a function to capture this formula. You see that? So I will first of all define it. I'll define the formula first. Define the function name. Let's say I'll call it interest like this. Okay. And I'll put how many arguments do I have or parameters do I have here? I can write it as principal, comma, rate, comma, time. Is it not? And what is the formula? I know that I is equals to what? principal times what? Rate times what?
Time.
Time. If, for example, I know there's a fixed time, it is always 5 years, or the interest rate is always going to be maybe 0.23, it's already constant, then I can put it there. You get? I can put it there. In that case, I only need to, how many parameters do I need? How many parameters will I need now? 2. Can you see that?
Yes.
Good. So principal times rate times time. Is it not? So whatever I get there, I want to return what? I. Isn't it? I want to return what? I. Best practice, please, anytime you are writing your functions, please always write a note what you are trying to do. Is it not? This function will enable you compute, right, the simple interest. Can you see that? So just write a small note there. Okay?
I have a question.
Yeah.
This comment used to confuse me because I used to think that comment was the pound key hash. But we see this one was just for long strings.
Okay, yeah. So the reason is that, you see, when we start getting to libraries, right? When we start getting to libraries, you see sometimes they will want to write, you see how they will try to describe, what the function is doing. So if I have, you see the function, right? You see the function. So like your help, let me see. I want to write help. Let me see, this question mark. No, not question mark. Trying to remember. If I want to bring out the help, how do you bring out the help function now? Did you see a help? For Python, if I want to bring out, star.
I think it's shift tab.
Okay, shift tab.
I think it's shift tab.
Shift tab. Aha, good, thank you. So shift tab, right? So you can see it now. Can you see that?
Okay.
It will not narrate exactly what you are doing there. You see it? So if I write interest, so shift tab, right? So it will just describe it for you. So the same way I have, what was the other function imported? Random. Was it random? Shift tab. Can you see what it was doing? But although they did not put a doc string there to explain, but most times it will be important that you also will describe it. So that when anybody is looking at, say, okay, what were you trying to do there? I can see what he did. Do you understand it now?
Yes, sir.
Okay, so that's the essence of it. You know, it's a bit different from when you are using comments, right? And now put, so this is another way of putting it. So if you want to put a comment there, so let me put this out. So if I had put a comment there, I just put hash there, right? And I run it. If I put here now, shift tab, can you see there's no doc string there? You see that?
Okay.
No doc string. But if I have put it in the doc string now, and now run it. So when I now want to document and now check what is done, it will now tell me what is there. That's the essence of it. So anytime you write your function, it's important, because remember we mentioned it at the beginning, as analysts, always document your work. Because this is something that everybody knows. You know, there are sometimes you want to create your own unique function to do a particular calculation. So it's important when you are creating it, you write what you are trying to do there. Do you get that? Is that clear?
Yes, sir.
Yeah, so that's the essence of what it is, right? So that's why you see, whenever you are at this stage when you are learning, any tool you are using, just stick to one tool and be used to it, you know. Because by the time you are used to different tools, you are used to R, you are used to Python, sometimes you start getting that confusion. Okay, you're writing your Python in R or writing R in Python. You get. So that's why sometimes just good to just understand the basics of it. If it was a R, you'd have just put maybe like help or just put question mark there, and the whole thing will come out, right? So that's the essence of your doctrine. So once we have done that, so I want to calculate what's the name of the function. What's the name of the function here? What's the name of the function now?
INTR.
INTR. So I'll put my parameters. So what are my parameters now?
Principal rate and time.
Principal times rate. So I'll put my number, let's say 10,000, 0.23 or 23, comma what? Maybe time for 10 years. Then to do my calculation. Do you see that?
Yes.
Now let me even see. What if we say print? Let me try this one. Your interest will be. Then I'll now put this, is not. Your interest will be. Can I see that now? Then if you now want, you can now put maybe. If you put in front of, I'll put at the end of it. Okay, let's put. Let me put here NGN. Can I see that? So you can see that, right? Then even if you want, I don't want us to start going into that level yet. But there are some instances where inside a formula, right? You want to create a function. Inside that function, there's another function again. It's not, so it's like putting a function inside the function. So instead of using function inside the function now, I will use lambda. So the same thing, who was asking I was not clear with this? Is this okay now? Who was saying that this was not clear?
I think it was Kolade.
Kolade, is this okay with you now? Is he still here? Okay. So we said that instead of writing like this, you can now use what? A lambda function, is it not? A lambda. So how do I write a lambda function now? How do I write a lambda function now? How do I write a lambda function?
You put in a variable first, like
So
maybe x
maybe
is equal to
I equals to what?
lambda.
Lambda. How many parameters?
3.
So I'll
Three
write
parameters.
lambda, instead of saying define the function, I'll write lambda. Lambda will be anything. Then I'll define the parameters. You know? So in this case, I have 3 parameters. So I have principal, rate, and time. Is it not? What's the expression? What's the expression?
P
Principal
time.
R times T.
times what? Rate
Rate times time.
times time. So you see, to write a lambda function, there are 3 things I need to do. First of all, define lambda. Just put lambda, number of parameters, colon, the expression. Do you see that? So it is what? Lambda, is it not? The parameters, then the expression. Do you see that? As well. So if I run that, so if I have I, so I have what, 10,000, 0.23, and what, 10. So I should have the same thing. So that's for lambda, right? So writing lambda what functions. And we are saying that sometimes, let's look at this. Maybe you want to write a function, right, to calculate something like so let's say, for example, we have, okay, let me use this. Maybe you have ax raised to power 2 plus bx plus c. You know, you know what they call the almighty formula?
Mm-hmm.
Yes,
Something
sir.
like that. Just imagine you want to write something like that, right? Now, in this case, how many parameters do we have? How many parameters do we have?
Like 4.
How many parameters do we have?
Well, 4.
One.
How many parameters do we have?
It's 4 now.
How
A,
many
B, C.
parameters we have?
4. Okay, so what are they?
A, B, C, X.
So A, B, C, X, right? Okay, so those are our parameters, right? So it means that, so let's look at it now. You know, normally when we want to do a calculation, we now say where X is equals to 1, right? It means here we have what? 1 here. We have what? 1 here, is it not?
Yes.
We have 1 there, is it not? Good. Now imagine now that you have your A, B, C. That means A may have its own values. Then where you have A having its own values, X can also have its own values.
Yeah.
Right? X can also have its values. So once we have done our A, B, C, they will now say where X is equals to 1. Now do the calculation. In this case, if we have written it, so if I want to write a lambda in this case, how will I now write a lambda function? How will I now write a lambda function for it?
A formula is equals to
Okay.
So I'm wondering if we should say
lambda.
if A is a parameter inside.
Okay, let's not use A itself.
A
Okay,
underscore formula. That's
okay,
almighty
let's say
formula.
A underscore formula.
Yeah.
All right.
It's equals to lambda A B C X.
Like this, right?
Yes.
Okay.
So A multiplied X to the power of 2.
So how do we now do that?
Shift 6, I think.
Like this.
Yes, 6. 2 to the
Like
power of 2, yes. Yes. Plus
okay.
B multiplied by X
Okay.
plus C.
Plus C. Good.
Yes.
So will this work?
It should work.
It should work, right?
Yeah.
Will this work? All right, let's try. Let's see. Okay, so you say A formula. It looks like it worked, Abby.
Yes.
All right, so let's now confirm whether it worked or not, right? So let's say A is what now? Let's use simple numbers so that No, let's assume everything is 1, 1. So if A is 1, B is 1, C is 1, right?
Yes.
And X is 1, what will be the value? What will we get?
1 plus
3.
1, 2, 3.
So at least we'll have 1 raised to power 1, is it not? 1
Yeah.
raised to power 2, is it not? Is 1 times, right?
Yes. Yes.
So that how it works.
3.
So if it was 2, 2, 2, 2, X is 2, what should we get?
8 plus 4, 12. 12 plus 2, 14.
So we should get 14, right? So which
Yes.
means 2 raised to power 2 is what? 4
4,
times this 2, 8.
8.
Is it not?
Yes.
Plus what?
2 times 2.
2 times 2, which is what? 4.
4.
Plus what?
2.
2. So give me what?
14.
14. So everybody, we agree with this now, isn't it?
Yes.
So let's now check now. So to confirm it now, it means that A formula will be what?
2.
2, 2, 2, 2.
Which will give me what?
14.
14.
That's great. Hey,
12.
enemies.
So what has happened now? Now, first of all, go back to the fundamental. Look at what we have written here. What is
Okay.
What is it?
8.
2 raised to power 2. What will it give me?
4.
Eh?
4.
So
How do you raise the Python? Fundamental.
Jesus Christ. No. It's X. It's
Double
times-
asterisk.
double
Yes.
asterisk.
Fundamentals.
You pushed us forward.
See that? Fundamentals. Okay? Good. You see why those basics, when we are learning there at first, you may just apply, why do I need that? Because sometimes, you see, if you work, that's why you always test run your code. Don't just assume it has worked. Test run is randomly to check. Okay, this is what I expect. So if I put it here, this is what it should give me. Before you go and put it to production. Because once you have got it wrong, every other thing you are going to calculate will be wrong. So always randomly test run it. Right? Always randomly test run it. Okay, so let's change it here now. So now put raised to power, is it not?
Yes.
2 there. All right, so let's run that and check. So do we see that now?
Yeah.
Good. So if we have done it like this, there are some instances now. So it means that we know our x, is it not? We have a, b, c. So no matter how we put it, we can also put a function inside a lambda function inside a function, a lambda inside the function. So for example, if I say define, what was the name we call this one? Okay, a formula. So let's say define a formula, right? Define a formula, right? Define a formula, okay? Now I want to put the parameters now, right? So in this case, I want A, B, C. Guys, I just want A, B, C. So I want A, B, C. Because I know that inside my formula here, right? This will be variable, right? Later, we'll now have this as a function here, where x can now take any value. Right? We'll now take any value that I want. Then I can now say, okay, return. So what would have done normally? I put the expression. And what would have been the expression? This would have been the expression here. This is the expression here, is it not?
Yes.
This would have been the expression here, right? But in that case, instead of me writing down, maybe I'll now write another, maybe Z is equals to this, then return Z. You know, we would have done something like this. Then
Yes.
now say return Z, right? Something like this. Now, instead of me doing it this way, what I would have done is just to call a lambda function. Now use lambda here. Is it not? And now say return lambda. Can you see that now? Now lambda will now be what? X. Do we see that now? Lambda will now be what? We'll now write a lambda function, lambda inside the function. Do you see how we can now combine them? So instead of me have written it one after the other, so I would have first of all have done this. Maybe I'll put maybe Z or X is equals to whatever. And then I'll say return X, is it not? Return X. I don't want this way because it means that every time I now write it, I don't have to go and be looking for what X will now be. Because I already have X. So if I have Z here, it will now be what? Return Z. Isn't it? Then I will now have to now define my formulas. Okay? Okay, let me run this first. He said unexpected what? What does this one mean? Unexpected indent. What does this mean?
The return is supposed to be the indent was one more extra indent there.
Where? Here.
Yeah.
Indent does not match any outer. So what again?
The one above. I think you should take the Z as well.
Here, right?
Yes.
Okay.
No, I'm saying take everything back up and do the indentation again.
Okay, take everything back up.
Yeah, right. Back to the colon. I think that way.
Here.
Yes, then the return as well.
Like this.
Yes.
Yes.
Okay. Good. So if I have a formula, so how many parameters do I have now?
But we have 3 parameters, but I thought we should have 4.
But we are supposed to have 4, is it not?
Yes, we didn't define X.
We didn't define X.
We didn't add X to the parameter.
So if I have put maybe 2, 2, 2, he's doing something else. Is it not?
Yes.
He's doing another thing for us. Okay. Now, if we have now said, okay, let us define X here. So what you have said, you have put X here, right?
Yes.
So if I have 2, 2, 2, then I put comma 2 here, is it not?
Yes.
This is what we have done before.
Yes.
This is what we have done before, is it not? So we are saying that instead of doing it this way, we'll now use what? A lambda function. Instead of me doing exactly this, right? I will now use what? A lambda function to now reduce it. So I'll now use for the first one, right? I'll now use what? I can now use what? Lambda. I can just say return lambda X, right? Return lambda what? X. So in this case, I don't need that. I don't need that. So return lambda what? X. Okay. So if I have it this way, let me run it and check. So if I want to now put a formula now, a what?
Formula.
It will now be what?
2, 2, 2.
Right? So that already is telling us. So we now need what? A formula now, right?
Yes.
For the function. Is it not? And what's the function there? Is that X? We have the formula already, right?
Yes.
We have the formula already, so we have put it there. So let me put it inside, maybe I'll put it inside B. Let me put it inside B now. right? So it means that what we have here is that what we already have inside here means that ax raised to power 2, that is 2x raised to power 2 plus what? 2x plus 2. Do you see that now? That is exactly what you have.
Okay.
Now, it means that if I want to now have x as 2 now, it means that I will now have 2 times x, is not, raised to power 2 plus 2 times 2 plus 2. Do we see that now?
But is this not? This seems way complicated.
It's way, that was the point here is that you can put a lambda inside a function. There are some
Okay.
instances that you may need this.
You
This is the
need
only
it.
thing that can help you. Because you don't want a situation where you are writing function inside a function. Do you get? I want to use one function inside another function inside another function.
Yes.
So in that case, instead of creating that one, I'll just use a lambda function inside it. Do you see that? We cannot use what? A lambda function inside it. Do you get that? So that's why your lambda, you just look at, let me just, because there's one, because you know, as analysts, there's one problem we're always going to be facing. Why actually you need Python? You know, all the Excel we have been learning, they are all in a structured form. You know your data,
Yes.
right? That be structured or unstructured.
Yeah.
You know that your data
Yes.
can either be structured or unstructured. Most times, the data we are working with are usually was structured. It's not in Excel. But you see, in the real world, the way the
Yes.
data will come, especially where data you do not generate within your own organization, you are generating from outside. Just imagine you want to now get, maybe you want to know how customers feel about your product. Is it not? You want to get their perception, is it not? Their sentiments. So you go to your, maybe your page, is it not? And try to what? Scrape the comments out, is it not? When those comments come, do they come in an Excel table?
No.
They are usually what? Unstructured, is it not? They are usually
Yes.
what? Unstructured. So I need to think about, how do I convert this unstructured form to now become what? A structured form. Do you see that?
Yes.
So that's why you will need to start thinking about all this. That's where Python now comes in to now help you what? Make that your unstructured data to become what? Structured. Okay? Just imagine that, for example, maybe this was a comment, right, that they have made. Maybe they say, your services are terrible. Can you see that? Your services are terrible, isn't it? Sometimes, you know what we can do? Because it's a text, you know, normally you can split it. You know, you can split your text, right? You know, you can split text.
Yes.
How do we split text? Comment,
Split.
this split,
Yes.
something like this split, isn't it?
Yes. Yes.
So you see, normally, if you now split it now, then you now look for, okay, if I split it like this inside A, right? What is the type for A? Is it a list?
List.
If
Yes.
it's a list, can I slice a list? So if I want to now get terrible, I want to get the word terrible. How would I get terrible now?
Can slice the list.
So I want to get terrible, what would it now be?
A3. A3.
A3, what's the easier way?
-1.
-1, isn't it? So I've gotten
Yeah.
one terrible out of it, isn't it? So you see,
Yes.
it means that every time I see a particular word, isn't it? I need to what? Slice it out, isn't it? I need to pick it out. And from there, I'll now create it into a column.
Okay.
You get that?
Ah,
I'll now
interesting.
create it into what? A column, isn't it? Just imagine now, maybe I have this one, maybe your services are good, or let's say it's positive, right? Another one we say negative, positive, neutral, positive, negative. So I'll now extract all those words. I'll now have a new column, positive, positive, negative, negative, positive, neutral, positive, negative, negative. You see that? I'll now convert those unstructured form into a column. Then I can now visualize it and now put in a pie chart. Do you see how it works now? So it is only
Yes.
through coding that you are now able to extract those kind of things. So do you see where your Python now comes in? So that's why sometimes we need to write certain functions to now extract. Maybe I can now have a bag of words, right, that I'm looking out for. Good, neutral, terrible, bad, disastrous. Do you see that? I'll have a bag of words. So go and look at inside that text. Anyone you see that looks like this, pick it out for me. Do you see that? So sometimes you now see how I'm not thinking about how will I now start thinking about it? Because as long as you can think about it on paper, okay, this is how I want to achieve it. Somehow you should be able to do it. So the most important is about think about that process first. Right? So the same way I would have done it this way, you'd have written a lambda function. Is it not? I would have written, so maybe I can just say text. Maybe I just say text is equals to now. I write lambda, maybe x, maybe whatever word it is there. Help me split it. Then I will now have what? What will I now have now? So I can now have comments dot what? Split. Is it not? Comment dot what? Split. Right? Comment dot split. So it means when I read text now, so when I've checked text now, what is it doing for me? It's now creating a function, is it not? A function. So whatever I write now, I now say, okay, so the text is what? This is a good product. Right? This is a good product. So what is it doing for me now? So it's telling me that what now? So
Max split is equals to -1.
Aha. So maximum speed. So inside it, so let me see now. Let me put that down. So if I call text, so that's a function, right? So inside that function now, what it has done, it has captured this for me, right? So if I want to now call it, okay, I remember, you know, when we are going into, remind me, when we are going to data cleaning, I remember before I start all these ones, before we get to data cleaning, and when we start data cleaning with pandas, I will recall this one for you so that you see actually how it's going to work. How it's going to work. Okay? Because this is already inside the function already, isn't it? So we have created like a function inside it. So when we now extracting maybe a huge line, I will now show you how to also add up. Because when you are dealing with this, first of all, you need to understand how the normally would work on its own. Is it not? Before you now start building it inside what? A function. So that's why most times I will try and break them for you step by step. Then before we start building, you know that even for example, when we're writing the functions, right? Let's say for example, we want to do calculation of a radius. How do you calculate radius? How do you calculate a radius? Maybe we want to calculate area of a circle, or how do you calculate area of a circle? So you can say area is what?
Pi square.
2 pi r, isn't it?
That's circumference.
That's circumference, right? So
Yes,
that
sir.
means area will now be what? 2
Pi r square.
pi arrow square. Something like this. Is it not? 2 pi arrow square, right? But if it was a radius, what will it be?
Pi.
Radius will be what? 2 what?
Radius is pi r square.
Okay. Pi arrow square.
Sorry, you said
Pi
radius.
Yeah, radius is you have to work your way back to radius.
Is it 2 pi r?
I think radius is the r inside.
Okay, yeah, so that's the radius. So it's like we're trying to recalculate it back, isn't it?
Yes.
Yes.
Yeah, so it's 2 pi, right? Is it 2 pi?
No,
So the radius now is
it's
that if I
area
know
divided by.
so
area
I will
over
need to get what area, is it not? So look at it now. You know, we have here, this is the area. We know the area. This is a constant. This is a constant. R is also what? But R is what we don't know. Right? So it means this one we have to cross. Right? This we have to cross. So which means that your area will not, your radius will now be what? If I know my area, what will now be the radius?
So the radius will be area divided by pi.
Divided by what?
Pi.
Pi.
Yeah, so the area is pi r squared.
Is that what about where is the square now?
So it's you have to find r
Like
squared.
square root of what
The
about
square root of area of pi.
square root of
where will
area
our
over
2 be now?
Mm.
Where will our 2 be?
So we don't have 2 in area, it's the circumference that has 2.
Okay, okay, then that's it now. So if that's what, so first of all, before you even do anything, then you must first of all know how you are calculating it, right? So if you say that was circumference you are calculating, and how maybe circumference is what? 2 pi r, right? You know, normally if you want to now define it, you first of all define what? Maybe let me say define what now? What should we call it? What should we call it? Let's say, okay, let me call it radius or whatever I'll call it. Let's call it radius. I know R. I'm looking for R, right? And maybe I have A, maybe area. I know the area, A is what? Say 2 times what? Pi. What is pi? Pi is a constant value, is it not?
Yes.
Yes, sir.
8 point what?
8.17.
1.4. Maybe times the R, is it not? Then I'll now say return what?
A.
Something like that now, isn't it? Which means if I want to now get my radius now, it's not, if I want to now get radius, I'll now say maybe radius is what? Maybe radius is 10. It should now calculate whatever I want to do there, isn't it? This is how normally would have done it, isn't it? Now imagine now that I now have different radius. Maybe when it's 10, calculate when it's 10, when it's 20, when it's 50, when it's 60. So just like I can now say, okay, maybe I can say when I is equals to, let me put maybe 10, 20, 30, 40, 50. You know, before we are calculating one after the other. What if I want to now see a different range of it? When it's 10, when it's 20, when it's 50, when it's 60. Do you see that? Now show me the radius. Or whatever, or the area, whatever you want to calculate. Do you understand that? So it means that if I'm now calculating, maybe I now say, okay, the area maybe equals to, let me put an empty list there, right? So it means that show me the area, right? So let's say this is area. So 2 pi r. So when the radius is whatever value, maybe 10, 20, 30, 40, 50. So calculate the area for me. So you should be calculating all the areas for me. So in that case, what do we now do? What can we now do?
For
I can now say what? For what?
for I.
Okay, let me put here as, let me call this one radii, right?
Okay.
So for what?
For radii. For radii
Okay.
in.
Is that what you want to do now? For I in radii now?
Yes. Sorry, for I in radii.
For I in radii. So what do you want to do? I can say A is equals to what? Radius.
Yes.
Because we already have a function already now.
Yes. Yes.
Is it not?
Yes.
We already have the
Radius.
function, is it not? So I will now
Yes.
put what I now, is it not?
Okay.
Then what do I now do?
Print.
Area dot what? Append what? Append what?
A.
A. Append A. Do you know what's happening here? We already have the area, right? Is it not? We know the function.
Yes.
Now you see how we have brought a function. So instead of me writing all these functions, you see I've already calculated something there that I'll now use in another place. Then I'll now use that to now do a calculation. Okay. So if I now call area, can you see what it has done? Do you understand it now? Do you see how we have created a function? We have now used a loop to now append it somewhere.
No, but the function, I thought the idea was okay, where the radii is the input already.
Yes,
Those are
it's
the
an input
values.
there. Yeah, exactly. Yes.
Yeah, so those are the arguments.
Those are now the arguments.
As opposed to entering the argument yourself.
Yeah.
It's already in the list.
You know, do you understand it now? So either me have to be calculating every time like this. You know, I would have done it like this, but there's another thing again. They call it mapping. You know what you are trying to do? You are trying to map 10, radius of 10. What's the area?
62.8.
20. What's the area?
125.6.
So what you are trying to do, you want to map it, isn't it? You are trying. It's what they call mapping. But let me see if that will work. So there's something they call map, right? There's something they call map. So I want to map what? What am I mapping now? What do I want to map now?
Radii to area.
So I know my. So let me see, which one do I already know? I know my radii, right? So this is, I know radii, isn't it? I want to map it with what now? I know my function. My function is what? Radius, isn't it?
Yes.
Okay, my function is radius, isn't it? So I know my radius, then radii. Okay, so map, all right? So let me put it in a list and see if that will come out. So let me put it in form of a list. Whether that will come out. Is it the same thing?
Yes, the same value.
It's the same thing, isn't it?
Yes.
So what I would have used to write here, I can write it in one line of code. Do you see that? So it's called mapping. It's called what? Mapping.
No, sorry, I didn't get the. It just brought out just the values. I didn't map them to the.
You see what I would have done here. This what I have written here. This code we have written here is exactly this code. It's exactly this code. You know, we have first of all created the
That's
formula.
all we have written.
Yes, that's what we have written. Yes.
We're using list, map, radius to radii.
Yes.
Ah.
Your radius is this function here now.
Yes.
Remember, I've written a function now to calculate the area.
Yes.
It's not. We have written a function to calculate the area. So anytime I call radius, I put 10 to calculate it for me.
Yes.
Is it not? I already have a list of my radii.
Yes.
Is it not? So what have I done here? Anytime I have the radius, right? Calculate the radius from wherever I have the value. So I know the function, is it not? The function is going to calculate 2 pi r. Where is my r coming from? Here now, is it not?
From the radii.
From the radii here, is it not? So what we have just done is simply use what? Map what? Radius to the radii. That's all. Then I put it in the list. And that's the same thing I will have. So instead of me doing that same calculation, so immediately I've written my function, right? Immediately I've written my function and I already have the list. So let's create another one. Let's create another example. Let's say we have, so remember that our function to create what? interest. Was it interest or so? So I think this was the function for interest. So if we have interest, let's say interest was what now? Let's say interest was what now?
Principal times rate times
Times
time.
rate times time.
Yeah, so if I have maybe 10 times 20, maybe 0.2, let's say now 5 years, right? So I have something like this, isn't it? Now, if, for example, I write a function that, so let's write another function now, right? Let's write another function. Now, in that case, we want to see what if interest rates. So I now have, let's say, rate equals to 10%, 15%, do you get 20%, 30%. So we now know the rate. We now know the rate. Because you see in this instance, all these other ones were constant. Is it not? All these other ones were constant. But it's only this rate that was changing. Do you see that? Only the rate that was changing. So if we are to define it now, say, define what? Rates. I know my principal. I know my rate. Is it not? I know my time. I have 3 parameters there. But you see, in this case, my principal will already be known. My rate can vary, but my time is already known. So in that case, I will only put one rate there. You know why we are putting only one rate? Because I already know that my interest, let's say my interest, I already know how much I want to invest, maybe $10,000. I know the rate, but the rate can vary, can be different values. And I'm investing it for how long? Let's say for 5 years. Do you see that? Can we see that? Then I say return what? Interest. Right? So what will I have done here? I will say, okay, my rate, so when my rate is what? 0.1. What will be my, how will it calculate the interest rate for you now? What will be my interest rate? 0.1. So when here is 0.1, what will I have?
5,000.
5,000.
5,000.
5,000. It's not, it will be about 5,000, right? When my rate is what? When my rate is 0.15, what will be my interest rate? 7.5, is it not? You
Yes.
understand what we are doing here now, is it not? So at this point now, we want to map it, is it not? So I now say what? Map what? Map what? The rate to what?
Rate.
To what? Okay, see, I called it rate. So let me call this name I rate, right? Let me call it I rate. So that will just, so there will not be confusion. So I rate. So let me put it in a list. Let me put it in a list. Can you see that?
So, sir,
Yeah.
because I think this is now taking us back again to one fundamental. What's the purpose of what does map do?
Map
The map.
helps you. So what the map is actually doing now is not, it's putting this value. What we are doing here, you see, we're doing one by one. Can you see this rate? Let's do
Yes.
another one. So we have what? 0.1, 0.5, 0. So if we do another one now, so rate 0.2. Rate 0.3. Can you see what that's done? You put it one by one. We're putting it one after the other, is it not? But now that I have a list, go through this list for me using this function and just put it for me in the list. That is exactly what you have here. Can you see that now? 5,000, 7.5, 10,000, 15,000. Do you understand it now?
So map is like it's like iterative.
It's
Map.
like iterating, but just put it in one place for me.
Okay.
What you'd have just still done, like for I in whatever, what we're trying to show you here. Can you see that? For I in this, you get go through the list and do that. And I've just used a simple map. That's exactly what I've done here. Because here, it's the same thing as writing what? For what?
For I in
I've just created that one, just call it interest, is it not? And I'll just call it what? Interest. Put an empty list there, is it not? And I'll say for what? I'll just call it interest. Right? And I'll say for
I
in what?
in rate.
I called it I rate. This is I rate, is it not?
Okay, I rate.
I rate, is it not? For I in what? I rate. What should I do? For I is what should we do? So let's say A equals to what?
Is rate.
We have written a function, right?
Yes.
Remember, we have written a function. Where was it?
Yeah, that's it, rate.
So we have written a function now, is it not? And now put the value there, is it not? Good. So now the A is equal to what? Rate
I.
Then what do we do next?
Then A dot append. Sorry, no.
Append
int dot append. Yes.
A.
A.
So if I now call interest, it's doing the same thing for me. Is it not? When I would have just used map to go straight. Do you understand it now?
Yes.
Map looks easier, is it not? But if I just taught you only map without explaining this for loop, it will never make sense. But when you understand that for loop now, okay, inside that map, actually map is doing like a for loop for me. But I don't need to start writing the for loop. Do you understand that?
Yes.
So that's what mapping does for you. Because when you are going to be cleaning data, right? When you are going to be cleaning data, it is all these things we are now going to be bringing together. Your map, your lambda, all of them will all bring all of them together. We have seen how to import, isn't it? We have seen how to import libraries, isn't it? We have seen how to import libraries. We have seen how to write a for loop, your if function. All these things, we are going to bring them together. Okay? So next week, we are going to start with what? NumPy. So next week, we are going to start with what? NumPy. Right? We are going to start with NumPy. Remember, how do you bring in library? If I want to bring a library, how do I bring in a library?
Import.
I'll just say import what? NumPy as NP. Right? Because that's the fundamental library we are going to start with. So when you are going into your data analysis.
Sorry, why did you add the as NP? Does that mean that every time we mention NP?
So if I say import, remember we say return random.
Random.
Remember this?
Yes.
As R. So it means anything I want to call random, call it R.
Okay.
You know in SQL,
yes.
This is called what? In SQL, this is called what?
What's it called again?
Customer name as customer. Do you remember this? Customer name as customer. What is this?
Alias.
It's called an alias now, alias.
Yes.
So anytime I want to say select from customer, it's not a customer name, I say select star from customer. So I'm no longer calling customer name, I'm not calling what? Customer. So the same way with your libraries. Instead of me always calling NumPy pandas, because sometimes the names of the libraries can be too long. For example, we have something like maths. There's something called maths plot lib dot pyplot. How will I always be remembering this name? Do you get dot pyplot? How will I'll just say as PLT. I'll just call it PLT. That's all. So they are called aliases. So when we are now bringing libraries, we'll now start bringing them. We just import NumPy as NP. So it means anytime I want to call NumPy, we'll call it what? Anytime I want to call NumPy, what do we call it? We'll just say NP dot maybe random or something like that. Something like, you see that? Because inside NumPy there's random inside. All right. So this is what we are going to be doing from next week. But please, I want you to go through your basics from beginning of what we have done till now. Remember, we are learning Python as data analysts, right? As things improve, right? There are so many things. Remember, we are just scratching the surface of everything, right? But it will be enough for you to start working as an analyst. Okay, so that's why I'm just picking the basic things that you need. But if you can go and do maybe a Udemy course that will take you through, or look for a YouTube video that will take you through the basics of Python programming itself, that will also be good. Okay? But remember, because Python is so versatile, you can use it for different things. That you know how to write a software with Python does not mean that you know how to use it for data science. That you know how to do a machine learning program does not mean you know how to write an app. Right? So you just choose where you are what you want to use Python for, because it's so versatile. Okay, so we are using Python as data analyst, right? So that's why I'm just teaching the basics that we need. But I think I've covered most of the basics that we require. Okay, so that we can try and start analyzing data with Python. You see, so far we have not seen anything like tables. Have you seen anything like a table?
No.
Now, because in a program, right? Normal program don't see anything like tables. What they understand matrix. They understand matrix. And this matrix is where you have your Python. Python simply, this your NumPy means numerical Python. So what you are seeing as a table is seen it as a matrix. Normally in the matrix, that's why I said try to understand your matrix. In Excel, Excel have rows and columns, These are your rows and these are your columns, So if I have here 1, 2, 3, this is 1, 2, 3. So if I have 1, 1, what does 1, 1 represent? 1, 1 represents what?
Row 1, column 1.
Row
1, 1.
column
That's row 1, column 1.
And in Excel, this is called what?
It's,
In Excel, this is called what?
A cell.
A cell, it's called what? A cell. So that means that Python only understands it in terms of a matrix. So if it sees 3 here, it implies that it's what? Row 1, column 1.
Column. Okay.
If I have 5 here, Python is seeing it as what? Row what?
3.
Row
Column
3,
3.
column what? Column 3. So it's reading it as what? A matrix. So the library that we are going to be using to be reading this is your what? NumPy. So now I say, please go through your basics of your Python functions. Then please read through matrix, basic matrix. Your basic what? Because that's how actually it's going to be reading as what? A matrix. Okay, that's the fundamental we are going to be working with. So next week we'll cover Python, NumPy. We'll go into NumPy next week. Is that okay?
Yes, sir.
All right, so please go through your basics, okay? Because once you understand this, when you start R, you will just see that it's the same logic you are using in Python that you're using in R. The only difference now is the syntax. But the same basic. Now I want you to focus on the basics. Because once you have understood these basics like this, even if you go to C#, you go to R, you go to other, it is the basic programming you have learned. You start the data type. How do I do for loop? How do I assign a variable? How do I do a list comprehension? You get, so those are the basic things that you are going to be working with. Okay. All right, guys. Enjoy the rest of your weekend. Take care.
Thank you, sir.
All right.
Thank you, sir.
All right.
Thank you, sir.